Hello everyone and welcome back. In example 1.2.6, we need to show that this subset of R2, the subset of all xy so that x times y equals 0, that this is not a subspace of the Euclidean vector space of dimension 2. So vectors with the usual addition and scalar multiplication. All right, let me graph this just so we could have a geometric perspective. We want the x times y is 0, so either x is 0 or y is 0. X is 0, that's going to be right here for all these elements here. X is 0, y is 0. Let me draw it in a different color. Y is 0 is right here. So I want to show that it is not a subspace. So I need one of the three properties to fail. So either 0 is not in it. Oh, but 0 is. So see, this is 0, 0. 0 is. So first property is true. This is not something you need to write. This is something you need to think. But all you need for this solution to be complete is to give me a counterexample for one of the properties. Property 2, if I take two elements and I add them, do I still get something on it? Let me show you something. What if I take one vector on the blue line and one vector on the green line? And what if I add them? So we have the parallelogram rule. In this case, it's even better. It's a square. We have this, and here's the square. It's no longer on the green or on the blue, so it's no longer in W. So I claim that property 2 fails. And so to prove that, I need to find one vector. Let me take 1, 0. That's in W, since x times y is 1 times 0 is 0. I'm going to take the second vector to be 0, 1. That's in W, but for a different reason. In the first case, y was 0. In the second case, x is 0. So 0 times 1 equals 0. So I have two elements in W, and I want to look at their sum. I claim that the sum will not be in W. 1, 1. 1, 1, x times y is 1 times 1. That's going to be 1, which isn't 0. So v plus w is not in W. All right, so as soon as you found a counterexample, one specific vector v, one specific vector w, both in your candidate for a subspace, as soon as you prove that its sum is not in W, then you've proven that property 2 fails, and so W is not a subspace of E2. Just by the way, I mean, we don't need to consider this, but property 3 is stretching and flipping vectors. If I stretch or flip something on the green line, I stay on the green line. If I stretch or flip something on the blue line, I stay on the blue line. So in this case, property number 3 would hold. So the only property that doesn't work is property 2. And so W is not a subspace.